Unit 6, Lesson 1, we're going to be solving equations. We'll deal with inequalities in Lesson 3. So we're going to model linear equations, and we're going to solve them both pictorially, drawing a picture, and symbolically, just doing the math. So in this example, we're just going to review a little bit of what we learned in grade 7 and grade 8. We are solving one-step equations. It takes one step to get to the solution. We have one positive variable tile. We have 3 red. Remember, in our textbook, yellow is always positive, red's always negative. And on the right-hand side of our equations, we have 7 positive unit tiles. The whole idea to solve an equation is to get this little variable tile by itself. So we have to get rid of the 3 negatives. We zero out with 3 positives. So what do? I just add 3. Whatever I do to one side, I have to do that other side. So I had to add 3 here. I got 3 here. This zeroes out now, and we are left with x is equal to 10. There is a different way that we can show equations by drawing an arrow diagram. So this can be a little tricky. You might have to watch a few examples to actually get it. But what we do with the arrow diagram is we always start with x, and we build the left-hand side of our equation. So if we start with x, it says x minus 3. So from my x, I subtract 3, and I get x minus 3. I'm already done building the left-hand side. So then on the bottom, we start on the right-hand side, because here's our equation, x minus 3 is equal to 7. So on the bottom rectangles, we start with the solution, and then we do its opposite. If we're subtracting 3 on the top here, then we're adding 3 on the bottom. And when I add 3 to 7, I get 10, and it works. You're building the equation, then you're undoing the equation to get to your solution. So x is equal to 10. Okay, so just watch a couple more before you come to me and ask me some questions on that one. Another class example, here's a one-step equation. 2x is equal to 10. If I represent it pictorially using algebra tiles, I have 2 variable tiles is equal to 10. Since the operation is multiplication, the inverse operation is division. So really what you're doing is, once again, you want to only get 1 variable tile by itself, but I have 2, so let's split the 10 into 2 groups. So if 2 variable tiles is equal to 10, then 1 variable tile is equal to 5. From the arrow diagram, I start with the x. The left-hand side says to multiply it by 2, and I'm done because I have the left-hand side. I put that equal to 10, and then on the bottom I undo it, so I start with the solution. If I multiply by 2 here, I divide by 2 here, and 5 should be my answer. So I want you guys just to stop the video, try these ones, come back, and make sure you get the right answer, or just check your answers. Welcome back. Model the following equations using either method. I'm going to do the arrow method first. Oh, actually, sorry, I'm going to do the algebra tiles first. Let me just erase that. And I'm going to do the arrow method for the second one. That's right. So I'm going to say that my white is positive and my blacks are negative. Okay, there's my, I'm just going to, okay, and these are all blacks because they're negatives. Okay. The whole idea is to get this variable tile by itself, so I have to get rid of these 4 positives. So I zero them out with 4 negatives. Okay. Let's see if I can actually do this. No. Let's see. Whatever I do to one side, I have to do the other. Oh, there we go. So I have to add my 4 in there. These zero out to leave me with x, and I have negative 11 on the other side. Nothing zeroes out, I just count out my black ones. Here on the bottom, let's see if I can actually just do this with, there, Maybe that might be a little faster. Okay, so I have 4m's on the left-hand side. Got 4m's. They're positive. Remember, I'm just going to keep my black or my white positive, my black or my negative. Here I have all positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm going to divide all of these up into my 4 groups already. So I got this, this, there's 4, 5, 6, 7, 8, 9, 10, 11, and 12. And let's get rid of that one. I did one too many. So if 4 m's are equal to 12, 1 m is equal to 3. Okay. In this one, I'm going to show you using the arrow diagram. Here we have y, and then we're minusing 2.4. We're building that left-hand side, so I get y minus 2.4. And then we're done, so that's equal to, we start on the left-hand, or on the right-hand side now. If I subtract 2.4, then I'm going to add 2.4, and y should equal to 8.9. So that's 8.9. Here, I'm going to do the arrow diagram again. Very difficult to use algebra tiles with decimals. To build the equation, I times 3, and I get 3x. I'm done on the left-hand side, so now I start on the right-hand side because those two are equal. And now I'm going to divide by 3 because I have to do what's opposite because I'm undoing it. And I get negative 1.2, and that's my answer. That's 1.2. So drawing the pictures can be a bit tedious, so models are helpful for simple equations. We use what's called inverse operations in order to solve more difficult. Now I'm going to use the word inverse and opposite operations like that as if they're synonymous. So if you hear me say opposite or inverse, it's the exact same thing. So the inverse operations, if you add, the inverse of adding is subtracting. If you're multiplying, then the inverse is dividing. We learned the inverse of square root, which was square, and the inverse of square is square root. So class notes, when we actually solve equation, we want to verify that our solution is correct. So you should always verify your solution. So when we verify, we substitute the solution back into the original equation and see if the left-hand side equals the right-hand side. So we're going to do some verification with our solving, and you have done verification in grade 7 and grade 8. So here we're just going to inverse inverse operations. I just showed you the picture off to the side just to make just to kind of ease you in. Here we have x plus 2 is equal to 9. I just put it in words, some number plus 2 is equal to negative 9, just so that you guys can get like warmed up to changing word problems into equations. I want to get my variable by itself, so I have to zero out that positive 2. The way I zero out the positive 2 is by subtracting 2. So I cancel that zeros out, and I get negative 11. It says to verify. So in verification, your left-hand side equals your right-hand side. I take, on the left-hand side of my equation was x plus 2, on the right-hand side was negative 9. I now say, because we just said that, or we just solved that this number, some number is equal to negative 11. So this number right here we're saying is equal to negative 11. So we take that variable out, and we put the negative 11 in, and I get negative 9. And since the left-hand side equals the right-hand side, you know you've done the math correctly. If you get negative 10 is equal to negative 9, then you know you've made a mathematical error somewhere. You gotta go back and check. Okay, so I want you to pause this video and try these ones. Okay, welcome back. So here, I'm not going to verify. I'm just going to solve these ones just to save some time. So here I have some number minus 5 is equal to 15. I want to know what that number is. I have to zero out the minus 5, so I add 5 to both sides, and I get a is equal to 20. Here I have some number plus 4/5 is equal to 1/5, so I have to zero out the plus 4/5. I do that by subtracting 4/5, and I zero that out, and I get m is equal to negative 3/5. On the bottom here, I have some number times 2 is equal to negative 19. The inverse operation from times is divide, so I'm going to divide both sides by 2, and I'm going to get m is equal to negative 8.5. Really be careful with your negatives. And here I'm just going to write this again. b is equal to 3 is equal to negative 6. Sorry, b divided by 3 is equal to negative 6. Opposite operation from divide is times, and I'm going to write my multiplication like that, not with a multiplication sign, because that may be confused with the variable x. The divide and the multiply cancel each other out, and I get negative 18. Okay, I'm not going to verify these because these are a little bit simple, and this is a review from grade 7 and grade 8. Changing those words into an equation for some students is very hard, so I'm going to just start again, like really reviewing the basics and then building those equations up to more difficult ones. So here we have, write the equation and solve. 3 times the number is negative 3.6. Well, this number, it doesn't matter what variable you give it, I'm going to say n. So I'm going to say that number has a variable of n. So n times 3 is equal to negative 3.6. We have our equation. We know we're multiplying here, so to undo a multiplication, we divide. And we have n is equal to negative 1.2. It does say to verify, so I'll verify this one just because it's a little different. Left-hand side, right-hand side. Sorry for the clicking, I don't have my little pen with me. I'm doing this on a mouse. So 3n, negative 3.6. So wherever I see an n, I'm going to replace it by negative 1.2, and I get negative 3.6. The left-hand side equals the right-hand side. I know I've done it right. Okay, so write the equation and solve. A number divided by 4 is 1.5. Again, it doesn't matter what variable you give it. I'm going to say it's p this time. So p divided by 4 is 1.5. I'm dividing, so to undo a division, I multiply. Whatever I do to one side, I do to the other. This division and that multiplication will cancel each other out. They undo each other, and I get 6. I'm not going to verify this one, but please feel free if you want to verify, make sure your answer is correct. I'm going to stop that video right here, and then we'll go on to solving two-step equations pictorially and symbolically.